Hi, my name is Tejashrita Goli and my teammates are Dharani Ravanam and Karthik Bommarti. Our project is to find green to concrete ratio and our objective aims to use AI image processing to analyze satellite or drone images and determine green to concrete ratio in urban areas. We will identify and classify areas of vegetation and concrete, and we calculate their ratio for urban planning and develop a method that can be easily applied to assess green spaces in cities. Initially, we proposed to implement a CNN specifically using a unit architecture. When we started working on the project, initially we used unsupervised learning model, that is k-means cluster, but we didn't get desired accuracy. So we started working in supervised learning model using TensorFlow unit, giving manual labeling to the images using RoboFlow. We faced challenges with boundary detection, so we moved to YOLOv8. My friend Karthik Bomatti will continue with the code implementation.
Hi, this is Karthik Bommarti. Today, I will walk you through the implementation of our project, starting with k-means clustering and progressing through various stages of improvement in our methodology. We started by implementing the project using k-means clustering. First, we loaded the image by providing the path and applied k-means clustering to classify different regions in the image. However, when analyzing the results, particularly the green area percentage, we observed significant inaccuracies. For instance, even when a completely green image was provided, the results were not as expected. This revealed the limitations of k-means clustering for our use case. To overcome these challenges, we transitioned to a more advanced technique, TensorFlow with Unit. Now, by using OpenArealMap, we obtained high-resolution images and created our own dataset. For labeling, we manually annotated the data using RoboFlow. And with this, we prepared dataset. We moved into Jupyter Notebook to process the data and train the model. Now, we loaded the images and their corresponding label maps and extracted the data. Moving on to next. By using TensorFlow, we passed the data. Yeah. We passed the data into unit model and prepared it for training. For optimization, we used Adam as optimizer. After initiating training, we saved the unit model as unitmodel.h5. We set the training run up to 50 epochs. However, the training has stopped early to 15, saying early stopping. This occurred because the loss became constant. As you can see here, and the accuracy is 100%. While this might seem ideal, such accuracy is unrealistic in real-life scenarios, and it was a clear sign that our model was overfitting. And the graph here generated during training shows this behavior vividly, highlighting the need for improvement in our approach. To address the overfitting and enhance performance, we transitioned to using the YOLO, which is better suited for object detection tasks. My friend Dharni will now take over and explain the next steps in our.
Hi everyone, my name is Dharani. So after facing all these challenges, we finally moved to YOLO model. So we have used the same dataset as we used in the TensorFlow, but we just changed the format of downloading the data. We have downloaded the data in YOLOv8 format, and this is the code we have taken from RoboFlow to download our data. You can directly download the file. And here from Ultralatex, we imported the YOLO, and I also imported a display and images for visualization. And then we have taken the home path, and this is where our training started. So we have passed data.ml file, which is the YOLO format of data, which contains the labeling, what are the labelings present, building, road and white spaces, and the path for test, training, and validation. This is how our models knows where is the path and what is where. And we also passed a pre-trained model, which is YOLOv8 segmentation.pt, which is a pre-trained model not specifically for our images or our project, but it is a normal pre-trained model which is used to detect the edges properly. And we have set the mode as training, and we also given epochs. Initially we have tried with 10 epochs, but we have changed it to 50 epochs now, and the image size is 640 into 640, so I have given image size as 640. So here our training started, and here if you see, we got box loss, segmentation loss, and the training has been started. So if you go here, our training summary is here. We detected buildings, roads, white spaces, and the results are saved in this path if you see. And if you go down, we also found the MAP values. And after the training, I just displayed the confusion matrix, and these are the graphs. If you see the graphs, these are converging down, which is good, but still we have box losses, segmentation losses, and class losses. We also have precision and MAP values increasing, which is good for our model. These are few images of the training. I just displayed it for you. And then we started with the validation. In the validation, I just given the same URL of data YAML, and I have passed the trained weights to the model, and I have set the mode as validation. If you see, the summary has given that it is detected buildings, road, white spaces, and the validation is stored into this path. And if you see, this is the confusion matrix we have drawn, but we will see this in detail. So these are the validation part. This is the when we run with 10 epochs, and this is with the 50 epochs. So this is the confusion matrix. Initially, if you see, the buildings are 2, the roads are 3, which is bad, which is just basic. But if you see, after 50 epochs, we have detected 35 images, 36 images, but we still have some confusion, like buildings are detected as background, but roads are detected as background, but which is good than the previous. And coming to mask PR, initially we got MAP value as 0.23. And if you see, graphs are also low. But if you see, after 50 epochs, the MAP value is 0.592, and the graphs are also good. So this is how we can see the difference. And then we move to the training part. In training part, I just given the image sources of the training testing. So I have given the URL of the testing, and then I have passed the trained path, and I have kept the mode as prediction because we are testing the model. And here we got the results, like we got buildings, roads, white spaces, and this is the path we have predictions are saved. And if you go, we can see the predictions how we got. I For a better understanding, I will show the predictions with the 10 epochs and predictions with the 50 epochs. So this is 10 epochs and this is 50 epochs. We will see few images so that we can get more clarity how it turned out. So if you see, initially our rivers, this is a river water body, but it is detected as building, which is wrong. And after 50 epochs, the water body is not detected as building, and buildings are detected as building. And we have we have road, and it is also detected properly. And we will see one more image. for more clarity. So this is the road. This is the road, and these are the green spaces. But if you see, the green spaces are also detected as road. But here, if you see, we properly got the shape, and roads are detected and buildings are detected best. So this is how our model got turned out. And for visualizing more, my friend will explain you how we visualized the training with an example. So Ashita will explain you that.
Hi, I'm Tejashrita Goli. Now we see the testing part. Now we take the image path. We will take the image path from the random image. We will copy the path and paste it near the image path. And if you see, we are passing the model path. Also here for a clear understanding, I am printing original image, combined mask, overlay image. We are passing the class IDs and masks. And then we are calculating the total masked area by adding building and road areas, then subtracting this with the whole image gives the green ratio. Now see the image. If you see the image, road is detected and masked, and building is detected and masked, and we can see the percentage below. The natural area percentage is given as 55.29 percentage, and concrete area percentage is given as 31.52 percentage, which is good. Now, coming to the applications of the project. Coming to the applications of the project, the first application is urban planners, second application is government, and third application is civil engineers. Like in this fast growing world, construction of buildings and infrastructure can lead to decrease of greenery all over the world. So implementation of this project will help urban planners, government, civil engineers to plan and construct in an eco-friendly manner. And next, coming to the future scope of the project, firstly, we have working on the shades and blur images, that is like adding more diverse data of shaded images to train the model. Secondly, we have dividing water resources, like refine the dataset annotations by adding water bodies such as rivers and lakes and even oceans. And coming to the third future scope, differentiating green to concrete ratio in span of time. Like by using satellite images, we could differentiate green to concrete ratio over years. By considering the uh, image image of 2016 and by taking the image of 2023, we could find the difference in between and we can differentiate between the green and concrete ratio between them. Thank you.